Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Arin, founder and CEO of WebRTC.Ventures. WebRTC.Ventures is a custom design and development firm specializing in live video applications, and we're here to help you take your live video application to production. You can learn more about us at WebRTC.Ventures. This is our last episode of WebRTC Live for 2020, so I think this is a perfect time for us to talk about things going wrong, since a lot has gone wrong this year. For today's episode, I'd like to welcome Germán Goldenstein, who will be talking with us today about WebRTC debugging. Germán is a senior engineer on our team at WebRTC.Ventures, a friend of mine, and joining us today from Buenos Aires, Argentina, where he helps our team build WebRTC applications for a wide variety of use cases. He spends most of his time doing WebRTC-related development for Vonage. He works closely with the team there, but has also provided consulting for our teams and our clients on video development in general. He'll be sharing a bit with us today based on his years of experience building and debugging WebRTC applications. So thanks for joining us today, Germán.
Thank you. Thank you very much for inviting me. So yeah, we are going to talk today about debugging WebRTC calls. I'm going to give you more or less a few tips and some insights regarding my experience. So first of all, let's start talking about some facts, things that we cannot deny. We have to speak always with the truth and face it. The fact number one is that bugs exist. They exist in all applications, all the systems, and WebRTC is not an exception. And we can have a WebRTC application that works great, but eventually issues happen. The second fact is that bugs are not fun. Communication issues have a big impact on people's lives. It is very frustrating that you cannot connect to a call, or that the other party in the call doesn't hear you or see you. Or, for example, right now that I'm doing this presentation, hopefully nothing is going to break and everything is going to work smoothly, I hope. And the third fact is that debugging a WebRTC call is challenging, but not impossible. And we have methodologies and tools to carry out this task. So the methodology in general terms is basically to collect the data, analyze it, make a diagnosis, and to try to implement a solution if possible. So first, let's see what are the most common WebRTC issues that we can see. For example, we can have connection failures during the call setup. We can have, for example, issues with the signaling, for example, with the WebSocket server. Yeah, I know that signaling, it's outside the scope of WebRTC, but this could be a point of failure. We can also have an error with the chaser process, where we send and receive the offer and the answer. And in this process, there is a set of steps that we have to follow in a specific order, and this may fail. So, for example, there could be a bug in the implementation. Also, there could be stun and tune servers errors. One of the typical problems is that everything works okay, fine, locally, but later in production, it doesn't work. And many times, it is that we don't have a tune server for relying the traffic when a direct connection between the peers is not possible. Once the call is set up, the connection can basically be unstable, or perhaps we change from Wi-Fi to 4G. And sometimes that requires a nice restart, a reconnection. And this process can also fail, and the call will drop. And of course, we can lose the connection. The connection could be bad, and it will drop. Other common errors are get user media failures. What you see here are the errors that this API, the get user media, can throw. For example, it is very common that the user, by accident or whatever is the reason, he or she just denies access to the camera and microphone. This is very common. And the other thing that could happen is that the site you are visiting is not using SSL. That is mandatory for get user media. And in that case, the error will be not allowed error. For example, there is another issue with the camera resource they do not access. So in this case, the error will be not readable error. Or for example, we want to use a device because you can specify the device ID, and that is not present. So the error will be not found error. And there are other types of errors, for example, for the constraints and others. There are also issues with video and audio quality. This is key, right? The situation is very common. The user says that he or she has a good connection, but later the network becomes unstable, and there is less bandwidth available, and that makes the packet lost and the latency go up. And as a consequence, it lowers the resolutions and the frame rate, which degrades the quality of the video. We have also issues related to interoperability between browsers. Today, almost the most popular browsers support WebRTC, like Safari, Chrome, Firefox, and all the Chromium-based browsers like New Edge and Opera. But there are still some small differences in naming of the APIs. For example, Mozilla uses the prefix most sometimes in some versions. So if you want to support all of these versions, you need to use, for example, the adapter.js, which is a machine to solve these issues. On the other hand, there are bugs in the new releases of the browsers. Those of us who maintain applications, WebRTC applications, sometimes we see that with new releases, we see new fixes. That is good, but sometimes there are new bugs. For example, in Safari 14.0.2, there is a known issue with the audio that sounds super bad for the first second, sometimes up to 60 seconds. So that is super bad. And the options that we have is either to implement a workaround on our side, on our application, which means that for a specific version of a specific browser and device, we implement that fix. And the second option is to file a bug, and we can do it, for example, in bugs, chromium.org, or WebKit for Safari, or Bugzilla for Firefox. So to start debugging, we need data, basically. And we have three ways to get this data. The first one is from Chrome WebRTC internal, which is a popular tool that Chrome offers to show all the data in real time, allowing to export a dump file. The second option is to recollect programmatically this data using the GetStats API in your application. That is a change that you need to do in your application. And there is also a third option, that is to integrate a third-party service that allows us to collect the data and visualize it on a nicer dashboard than WebRTC internals. So let's start with WebRTC internals. If you are not familiar with this tool, you just have to type Chrome / WebRTC internals in a new tab, and you will see a screenshot, a screen like this. So the first thing that you will see is that you have tabs there, and the first one is for the get user media request. And what you are going to see there is the video and audio constraints used by each request. Then we have a section for each peer connection. So where we see there the configuration for the peer connection, which, for example, which as iServers we use. In this case, for example, we are using Stone only. Below, we see the API trace, which are all the actions, the events, and the callbacks from the peer connection that is ordered by datetime. And this is very useful to understand how was the call set up. So, for example, the first event, we see the transceiver added, which occurs when we use the add track API, and that is basically to add the audio track and the video track to the peer connection. Here, something that we can verify is that the expected tracks are there. For example, if the audio track is missing, it might be that the user doesn't have a microphone. We can also see the options we use to create the offer. In this case, we are saying that we want to receive video and audio. Another important event is the set local description, which always occurs after the create offer. When we click on that option, we will see the local SDP, which is a big text written in a specific protocol that is used to exchange information between peers. And it looks like that. And at the high level, for example, we can find information about ports, protocols, and codecs for video and audio. For example, we see here in this case that I'm using for audio, B9 for video, and the ports are 9 for both, and we use UDP. And we can see the same with this reset remote description, which happens when we receive the answer from the other peer. And we can see, for example, in this case, the SDP of the remote peer. There is another event that is interesting to see, that is the signaling state change, which is fired every time we call the set local description or the set remote description. And it shows the new signaling state. For instance, when we set the set local description with an offer, the state goes to have local offer. That means that you have a local offer. And when we call the set remote description with an answer, and in that case, the state goes to stable. That means we have the offer and the answer, both. So this event is useful to see the signaling state before setting the local or remote SDP, because there is a known issue that is called SDP glare, which occurs when two-peer connection creates the offer at the same time and send it to each other at the same time. So once they attempt to set the remote description using the offer received from the peer, the remote peer, the peer connection will throw an error saying that it is not allowed to set a second offer. The name of that error is khab local offer. Another important event to see is that is ICE connection state change, that it is fired when the peer connection state change, basically. No, so normally we will see there how it goes from checking to connected and complete, indicating that it is the peer connection is connected. But when the connection fails, we will see a failed value. So yeah, this event is useful to see exactly when the call is dropped. Below that, we are going to see the stats, which are the reports that we can find basically by calling the GetStats API, which contains metrics for the network, for the tracks, and from the RTP media streams. This data is shown in real time because it is updated every 1 second by calling GetStats API. So let's see an example of a report. This one is the RTC ICE candidate, which shows the IP addresses, port numbers, and the candidate type. And we have it for both the sender and the receiver. For example, here we see what is my IP address and my port, and the protocol is UDP, and the candidate type is reflexive, which means I used Stun to connect. So in the case I use Stun server, we will see relay in place. For the remote candidate, in this case, the candidate type is host, which means that the IP that appears here, it is the true IP of the remote peer. The RTC media stream track report is useful to see, for example, if the track is ended. If you see ended in true, that means you won't hear anything from the audio track. This one is the outbound RTP, which has metrics for the audio and video stream that we send to the other peer. In this case, I'm showing the outbound RTP for audio. There is another one for video. So you can see here, for example, the packet sent and the byte sent that are important to calculate the bit rate and the packet loss ratio. These two calculations are important to measure the behavior of the network. And the same can be seen with the inbound RTP that has the data from the RTP video stream or the RTP audio stream sent by the remote peer. In this case, we can see also the packet loss, the resolution, the frame rate. In the case of the packet loss, this value lets you know how many packets were lost during the transfer. In the remote inbound RTP, another interesting report, you can get the packet lost for the sender, along with other relevant information that is jitter and round trip time, which expressed the latency. For example, in the case of round trip time, an acceptable value is between 100 and 400 milliseconds. And yeah, the thing is that looking at like this, the data in this way, in this format, to understand video and audio quality issues is not easy, because this data is cumulative in general. For example, the packet lost, the packet sent, the bytes sent, this data is cumulative. It grows over time. For example, if I show you the number of packet lost, you can say, okay, there is packet lost. But the important thing is to see the evolution of the packet lost over time. For this reason, WebRTC internals offers this same data in the form of graphs, where the variation of each metric is seen over a timeline. And that way, it is easier to see, for example, when the packet loss starts growing, or the bandwidth decreases, or the latency increases. For example, this is the report that I showed you before, the remote inbound RTP. And here you can see some spikes. For example, in the case of the packet loss, is strongly went up at a certain point. And there are also spikes in jitter, which is bad. And the RTT was increased. And here in the outbound RTP report, we can see how at a certain point, the bits per second and the packets sent per second went down. So watching this, we can suspect that in this period of time that I'm highlighting, the video quality basically dropped. It is also useful to see what is the bandwidth that we have in the candidate pair report. There is a metric that is the available outgoing bit rate that represents the available bandwidth estimated to send the video. And this is relevant because it helps you to quickly verify why the user had a low video and audio quality. So WebRTC internals gives you the possibility to export all of this information. You can basically create a dump, which is a JSON file, and then you can import it into some other tool that is capable of parsing it and visualizing the data. There is one that is open source made by Philip Hankel that, well, you know, Philip Hankel is like a guru at WebRTC. So thank you for this tool, which allows you to import the dump, and you can see it in a more friendly way than the small graphics that WebRTC internals uses. Okay, so what if you want to programmatically get these reports? Of course, you are not going to ask to your users to have WebRTC internals opened while they have calls, just in case they have an issue and then they export and send the dump to you. That is not going to happen, at least on production. So what you can do is to recollect the data programmatically using the GetStats API. So here is the snippet code that is showing how to use the GetStats API, which returns an RTC stats report object, and then you can access to each one of the reports for that specific interval of time. In this case, what I'm doing is something dumb. Basically, I'm showing in the console the audio round trip time that is in the remote inbound RTP report. But what you basically can do is to recollect that data and send it to a server for analyze it later. Another option is to integrate third-party services such as call stats and test RTC that are used for testing and debugging both. And if, for example, if you use WebRTC CPass, it might be that they have their own tools. For example, Bona has an inspector, which it has a lot of other information, so it's pretty cool. And if you want to use an open source option, you can use RTC stats that allows you to recollect the information from GetStats and send it to a server and then visualize it on on a similar way that is on WebRTC internals. And the only thing you need to do is to copy and paste one line of code in your web page. Finally, I wanted to share some resources. The one I personally use often, for example, the first one is the W3C WebRTC stats description. You will find all the specifications for each metric and for each report. I usually consult this to understand what is what. And for example, sometimes I need to refresh the memory and some concepts. So yeah, that is very useful. And there is a second link that I put there for testing Zoom and Turn servers. There is a page on WebRTC GitHub.io. It's called Trickleize. It is cool. It creates a peer connection with the ICE servers that you specify, and then you can see how it works. The third one is a WebRTC troubleshooter to check the video, the microphone, and the network capabilities to send and receive media over WebRTC. There are many of these, but this one is one that I use. And the last one is WebRTC, which is basically popular peer-to-peer WebRTC demo. That's it. But I personally use it a lot to validate browser bugs. Basically, what I do is to try to reproduce the same bug that I see in my application in WebRTC. That is simpler. So if I can reproduce the same issue with the same repro steps, then it means that the issue is in the browser. And if not, that means it is in my application, so I need to work a bit more to fix that. So yeah, thank you very much for listening. I expect you are still there awake. Hopefully it wasn't that boring.
Thank you very much, Germán. Great presentation, a lot of great information in there. I hope that over time we have a chance to go over more of that in depth in other posts or videos on WebRTC Ventures. Germán, I think one of the last things you said there's a very valuable tip to use a publicly available sample application as a way to test if a problem is unique to your application or something in the browser's implementation with WebRTC. Although certainly WebRTC is much more stable than when you first started working with it, every browser release can still introduce discrepancies, and so I think that's very important to start with. When you look back at some of the data you were collecting from GetStats in your presentation, are there values that you expect to see for stats like packets sent or bytes sent? I mean, how do you know what are good numbers, or do you just look at the consistency of those, the trends of those, and the graphs of things like bytes retransmitted and packets lost?
Yeah, basically, you can use the packet sent and the byte sent for calculate the bit rate and the packet loss ratio. And those are the numbers you need to see to evaluate the network. Basically, you use the packet lost and packets sent to calculate the packet loss ratio, which is going to say, for example, you can calculate the percentage of packet loss that you have in an interval. For example, a good number to see for the packet lost depends on the codec and if it is audio or video. For example, in the case of Opus, it can handle more packet loss than video. It can support up to more or less 20-25% packet loss, and more of that you will definitely perceive issues there. And in the case of video, it's not recommended to have more than 5%, depending on the resolution that you are publishing. Basically, it's the same for the bit rate. That depends on the resolution and the frame rate. What is the recommended bit rate that you need to have a decent video quality? For example, for HD, if you want to publish in HD, it is recommended to have more than 300 kilobits, 350 kilobits per second. And if you want to publish in VGA, you need less than that. You need at least 200 or 250 kilobits. And the same for QVGA, the lower resolution. You need less. You need 100, 150 kilobits. And yeah, it's important to see the combination of the bit rate and the packet loss. It's better to have a low packet loss and the better bit rate as possible, of course.
Right. Okay. So it's interesting, though, how those do change based on the architecture of your app. We have a couple of questions from viewers now. Onur wants to know, do you recommend a test application that can be installed on both sides of the call?
Yeah. For developing, you can use, for example, Selenium, or you can use Kite. Those are useful for testing different browsers from both sides. And yeah, you can have, as I said, there is another commercial solution that is super complete, but yeah, you have to pay. That is Test RTC, but it is super recommended to take a look at least to that tool, because it is super complete. You can test a lot of things there.
So, Germán, you can use one of those when you have control over both sides of the application, both participants for testing. But if you're using this with production users who you don't have control over, or it's difficult to get them to look at things like WebRTC internals for you, then I guess building that into your application via data logging from the data you can get from GitStats, that's probably the best way to go, right?
Yeah, exactly. It basically helps you to measure the media, the connection. Also, you can see what is going on with the Stone server, the Turn server. So these are things that I've shown you before when I was showing the slide for WebRTC internals. So these kind of tools present you that information in a nicer way to understand what is going on.
And Alberto asks, could you share with us any real-world examples that you know of where WebRTC internals helped you to track down a bug?
Yeah, I remember one time that I used WebRTC internals to inspect, for example, the audio level of the inbound RTP. Basically, there is a bug in Chrome that sometimes you see stuck the audio level. Sometimes that happens when you start like receiving the video, and at the same time, the other party mute the video off. So at that point, something is going on in Chrome internally. I don't know why, but what I see in WebRTC internals is that the audio level goes to 0. It is like stuck there. And I'm receiving total sample received, which is a metric that said that I'm receiving audio, but the audio level is 0. The audio level is 0 when it is basically mute the microphone. But if it is not on mute, that means you should. So that is a way that you can inspect the behavior and even, detect weird things there with metrics. And that was one time that I discovered that, and we basically implement the workaround. That was to implement a watcher there listening all the time those stats to detect that weird scenario. So and the fix was to rebind the source object. That was the solution, basically. It's a workaround. It's not definitely a fix. The fix should be from Chrome, of course. But as I show you, there are workarounds that you need to implement in the meantime, right?
All right, thanks, Germán. We have one other question from Ayan. Are there any tools available to debug the turn server if you're using a server like Coturn? How could you go about debugging that?
Yeah. To monitor the turn server like Coturn, I show you one example of the resources that you can use. That is the trickleized, and you can basically debug what is going on there. You can basically put there the IP of your the IP of your turn or stun, and see how it behaves with the different protocols with UDP or TLS or DTLS. So you can inspect there what is going on. This page throw you a lot of information to debug what is going on. Also, thanks for mentioning that. Coturn is a very popular turn server. So I recommend that a lot. And do not forget to use Turn, because you will save a lot of issues, definitely.
Yeah, that's probably one of the more popular questions out there that people ask when they're trying to follow a simple WebRTC example on somebody's blog, and then they get it to work on their computer, but then it doesn't work when they deploy to production the first time. That's often because they didn't know that they needed to set up a turn server. So Coturn's a great project to look at. And then, as you said, using trickleice if you need to debug it. Well, thanks again for joining us, Germán, today and sharing with us so much of your experience. Really appreciate it. We'll be posting this video to YouTube as well as to our blog at WebRTC.Ventures. We'll be back soon in 2021 with more excellent WebRTC content for you. And if you want to keep up with those future events, just follow us on Twitter at WebRTC.Ventures or join our email list at WebRTC.Ventures. Germán, thank you again. Thank you everyone for joining us today. Let's make it live.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.Ventures to learn more about our custom design and development services and to learn more about upcoming episodes of WebRTC Live.